Welcome to our YouTube channel, Maths Point. In our last tutorial, we talked about the triangles and then we saw the different types of the triangles based on the lengths of the sides, and then we also saw some types of the triangles based on the measures of the angles. Then we also read about some properties of the triangles in which we saw angle sum property of a triangle and then exterior angle and its property. Now in our today's tutorial, our focus will be on the median and altitude of a triangle. Let's start our today's tutorial with median of a triangle. We know that triangle is a three-sided polygon. Just like here, we are having a triangle with three vertices A, B, and C. So we are having a triangle ABC here. And now median of a triangle is defined as the line segment joining the midpoint of a side to its opposite vertex. Since in this triangle we are having three line segments and we know that every line segment has one midpoint. So here in this triangle we are having three line segments and every line segment is having a midpoint. For example, if we will take this side BC and if we'll consider its midpoint as D, then it is the line segment joining the midpoint. That means we will draw a line segment which will join this midpoint D to its opposite vertex, and here the opposite vertex is A. So this line segment AD becomes our median. And this D is midpoint of the midpoint of the side BC. It means it divides this side into two equal parts. So we can simply say that BD is equal to DC. That means in this triangle, D is midpoint of side BC and its opposite vertex is A. So we can say AD is median of the triangle ABC. Now we will look at some properties of median of a triangle. For example, here we are having this same triangle ABC again, and since there are three sides in this triangle, so each side is having a midpoint. Let's suppose D is midpoint of the side BC, E is midpoint of the side AC, and F is midpoint of the side AB. Now, since there are three sides in this triangle, so three midpoints, and these midpoints or these sides are having opposite vertices. So we can join this midpoint D with A. So we'll be having AD as median of the triangle ABC. Similarly, if we'll join F with its opposite vertex C, then CF becomes the median of the triangle. And similarly, if we will join E with the opposite vertex B, then BE becomes the median of the triangle. And we can see that all these three medians are meeting at a point. For example, this point is point P. So we have every triangle has three medians as there are three sides in a triangle and every side has a midpoint and opposite vertex, just like we saw here. Side BC has a midpoint G and its opposite vertex is A, so AD is the median. Similarly, the side AC is having E as the midpoint and B is its opposite vertex, so BE becomes the another median, and again F is midpoint of the side AB and C is its opposite vertex, so CF becomes the third median of this triangle ABC. So there are three medians in this triangle ABC. Then the three medians always meet at a single point, and just like here we saw that these three medians meet at this point P, no matter what type of the triangle is, since there are different types of the triangles we saw. So in every type of the triangle, the three medians meet at a point, and this meeting point is known as centroid of the triangle. So this point is centroid of the triangle. Then we have one more property. It says each median divides a triangle into two smaller triangles of equal area. If we will consider this AD as the median, then the triangle is divided into two parts. One is triangle ADB, and on the opposite side of it, it is triangle ADC. So this median divides the triangle into two smaller triangles of equal area. That means we can say area of triangle ADB is equal to area of triangle ADC. It's one more property of the median. Then if we will see all these three medians together divide the whole triangle into six smaller triangles, and it says that the three median is divide the triangle into six smaller triangles of equal area. That means all these six triangles will be having equal areas. So these were some properties of median of a triangle. Now let's see the another point, that is altitude of a triangle. So we said median of a triangle is line segment joining midpoint of a side to its opposite vertex, but altitude of a triangle is perpendicular from vertex of a triangle. So this time we are taking one of the vertices of the triangle, and then we are drawing a perpendicular from this vertex to the opposite side. Just like here we are having this vertex A and its opposite side is BC. So we are drawing a perpendicular from this vertex A to the opposite side BC. For example, it intersects BC at D. So this AD becomes altitude. Since it is perpendicular drawn from vertex A to the opposite side BC. Then this side on which the altitude is drawn, it's known as base of the triangle. So here BC becomes the base of the triangle. So altitude is simply line segment drawn from, or we can say perpendicular drawn from vertex of a triangle to its opposite side. And this side on which the perpendicular or on which the altitude is drawn, it's known as base of the triangle. Thus, in this triangle ABC, AD is altitude and BC is base. Now, let's see some properties of altitude of a triangle. Let's suppose ABC is a triangle in which there are three vertices A, B, and C. If we will draw altitude from vertex A, for example here it is AD, then similarly we will consider B as the vertex and we will draw an altitude from vertex B to its opposite side AC. Let's say that it intersects AC at E, so BE is another altitude, and then we will take vertex C and its opposite side is AB, so here CF becomes the another altitude. So we saw here that in this triangle ABC there are three vertices, and from three vertices three altitudes can be drawn. So if we will consider AD as altitude, then its opposite side is base on which in this altitude AD is drawn, then base will be BC. Similarly, if we will consider BE as altitude, then base will be its opposite side, that is AC. And if we will consider CF as altitude, then base will be its opposite side, that is AB. That means the base changes as per the altitude. So we saw here that every triangle has three altitudes, as there are three vertices in a triangle and every vertex has an opposite side. Then the three altitudes meet at a point, just like here we can see these three altitudes meet at this point. and this point is known as orthocenter of the triangle. That means here this point P is orthocenter. In case of medians, the point of in the meeting point of the medians of a triangle is known as centroid, but the meeting point of the altitudes of a triangle is known as orthocenter. Then this altitude makes 90-degree angle with the base, as we said that it is a perpendicular drawn from vertex to the opposite side. So it's obvious that it makes a 90-degree angle. Then there is one more point and it says the altitude can be inside or outside the triangle. Here in this triangle we saw that all the three altitudes are lying inside the triangle, and it is the case of an acute angular triangle. In an acute angular triangle, all the three altitudes always lie inside the triangle, just like in this case that we took. So in this triangle ABC is an acute angular triangle. That's why all the three altitudes lie inside the triangle. Now, if we will take the case of obtuse angular triangle, just like here, ABC is an obtuse angular triangle in which angle B is obtuse angle. Now, if we want to draw altitude from vertex A, and altitude is a right angle, altitude is a perpendicular that is drawn on the base. So considering this vertex A, its opposite side is side BC, and if we will try to draw perpendicular on it, it will not, it will never lie inside the triangle. So for that, we have to extend our base BC. That means we have to go outside the triangle and only then we can draw a perpendicular from this vertex A. Suppose we extended our base CB up to point E. That means this is extended part of our base BE, and then it intersects this extended base BE at point D. Thus, to draw the altitude in such a case where it is not possible to draw the altitude inside the triangle, our altitude lies outside the triangle. So we saw here that altitude lies inside the triangle in case of acute angular triangles, and in this case we saw that altitude can lie outside the triangle as well. Now if we will take the case of right angular triangle, we know that in a right angular triangle one of the angles is 90 degrees. So here if we'll consider ABC as our right angled triangle, so here if we will try to draw perpendicular from vertex A, its opposite side is BC, and this AB is the altitude that can be drawn from this vertex A. So AB is considered as altitude. Then BC becomes the base. But if we will try to draw altitude from vertex C, then CB becomes the altitude and AB becomes the base. So it simply means the two sides of this triangle ABC act as altitudes. So we can say in a right angled triangle, two sides are altitudes themselves, just like here AB and CB. These are altitudes, and considering one as altitude, another becomes base. And similarly, if we'll consider AB as altitude, BC becomes base, and if CB is considered as altitude, then AB becomes base. Then another altitude can be drawn easily from this vertex of right angle, that means from vertex B. On the opposite side, just like here, it's BD. So we saw that altitude can lie inside a triangle, altitude can lie outside a triangle, and altitude is the two sides of a triangle in case of right angled triangles. Now, one more point is, in an equilateral triangle, all the medians and the altitudes coincide. That means in case of right angled triangle, just like here, if we'll consider ABC as right angled triangle, then D is midpoint of BC, A is midpoint of AC, and F is midpoint of AB. So if we'll join D with A, it becomes the median. If we'll join F with C, it becomes the median. And if we'll join E with B, it becomes the median. But in case of equilateral triangle, these medians are altitudes as well. That means this AD is median as well as altitude. So here in case of equilateral triangle, medians and altitudes coincide. So in case of this equilateral triangle, all the three medians are altitudes also. Similarly, in case of isosceles triangle, the altitude that is drawn from the common vertex of equal sides that coincides. Just like here, if we'll consider ABC as isosceles triangle in which AB is equal to AC, so it becomes the isosceles triangle, and the common vertex of these two sides is vertex A. So if we will draw the altitude from this vertex A to the opposite side, for example BC, then AD is altitude and it is median as well. So here in case of isosceles triangle, only one median and altitude coincides, and it is the one which is drawn from common vertex between the two equal sides. So in our today's tutorial, we talked about median and altitude of a triangle, and we saw some properties related to them. So I hope you understood it all. Thank you.